Hello, everyone. All right, so let's get started. So thanks for having me today, and I will be talking about building microservices in Python. And before I start to talk about this topic, I want to explain a little bit who am I and what I've been doing in the past 6 years or so. So I'm a Python developer at Mozilla Corporation working on Firefox. I've been doing that for like 6 years or something. And I was hired back in 2009 to work on some Python services. Basically, back then, Mozilla was two things: the browser and a bunch of PHP websites and services. And they wanted to move everything from PHP to Python because, you know, Python is fantastic, right? And so they hired me in order to do that, and I was the first person in the services team to bring some Python knowledge, and it was very interesting for me because I had the opportunity to set up a lot of things at Mozilla around Python. And the first job was Firefox Sync. So how many people here use Firefox? Well, that's pretty good. More than the share in the market, I guess. Well, we have great web developers tools, right? So anyways, so when you use Firefox, when you try to sync your bookmark, it sends some calls to our server, and that's the thing I was working on back then. It's a web service on the top of a MySQL database that allows you to synchronize bookmarks across your browser if you use the same identity. Nothing fancy, but it does have a lot of users and requests per second. Anyway, so I've built other web services in the same vein, and right now I'm working in the Mozilla QA team, and I'm building testing tools. So I'm working on tools to do some load testing, integration testing, and stuff like that. And whenever I can, it's in Python. So this is my email, and this is my Twitter handle. All right, so why microservices? So that's an interesting story. So basically, until last year, I didn't ever use the term of microservice because, I mean, when we build service, we just build service, and the fact that it's micro or macro or whatever doesn't make any sense to me. And I was approached by the Pact editor. Do you know this editor? They have quite a few books in the market, and they were asking me if I would agree to write a book about microservice. And when they asked me that, I was like, no, I don't know nothing about microservice. I just write services, like plain services. And I said no, and then I started to look at what people meant by micro when they talk about microservices. And there were a few interesting things about that. So I ended up saying yes, and the talk I'm giving today is about what I'm doing in the book I'm writing around microservices in Python. And why Python? Because Python just shines at it. Well, Python shines at a lot of stuff when it doesn't have to run really fast. But for writing microservices in general, it's a good idea to use Python. All right, so what's a microservice? I'm pretty sure people here, so how many people are developing in Python here? Can you raise your hand? All right, and how many people are writing server-side stuff, like just like plain JSON API and stuff like that? Do you do that? All right. All right, so what's a microservice? So a microservice is basically a very, very small application that focuses on doing a single thing. For example, if you build, I don't know, if you build Amazon, the feature where you are going to apply some promotion to some articles on Amazon, that might be a microservice separated from everything else. Or if you build a reporting system that's going to send out some emails to some people, that could be a microservice. It's one brick of your whole application, one single brick of the puzzle, and it has a single responsibility. And you can, when you create a microservice, you can give it to a team, and the team can work on it, can iterate over it, and they can be independent and provide this feature like they would provide a lib on PyPI or something like that. And at the end of the day, the final application is the combination of all those services, all those microservices to create an application. So the benefits, there are tons of benefit to do microservice. The first one, like I said, is the separation of concern. I mean, if you ask a team to create a reporting tool, they can do it independently from a big application. They can create something that would work for several applications, and they don't have to do it inside existing application. At Mozilla, we have a couple of Django websites that are like super big. One of them is the Mozilla Developer Network, and there is another one, the addons.mozilla.org. Those websites are huge. They get like 10,000 requests per second on some of their APIs. It's really big. And if you want to create something inside this application, sometimes you have to run tests that takes for 2 hours to finish. And when we ask someone to create, I don't know, a new feature, they're like, yeah, no problem, I can do that. And then they all get depressed because they have to understand everything, how everything works, because the app is so big. If they do it in a microservice, they can do it something completely separately and then plug it inside the big application. So this separation of concern, the fact that you can create smaller projects that are easier to understand, easier to iterate over, and easier to debug, etc., is a big benefit. And last but not least, it gives you more scaling and deployment option. Like, for example, back at the reporting example, if my reporting tool is calling some kind of, I don't know, exotic PDF creator, and it takes a lot of the CPU, if this is a microservice, and if this microservice does only that, I can like deploy 10 boxes of this microservice independently from the main application and scale it in order to do it. I don't have like to scale my whole application. It provides me more options to do some actual deployment. The risk, well, so there are quite some benefits, but there are a lot of risks when you start to do microservices. The first risk is if you do a bad design decision, you decide to split out of your main application this tiny little microservice, and then 6 months after, you just realize that it doesn't work. Every time you're going to change your microservice, it's going to impact like 10 other microservices, or it's going to impact your main application, and you realize that you have more trouble than benefit from having this microservice around. And this happens quite often. Quite often, people want to create a bunch of microservices, and they end up with something that's just messy. So that's one of the risks when you do microservices. The other problem is, since you moved the complexity from class and function interaction to network interaction, you might add a lot of network overhead. If I call your web page or your web service, and this web service in turn is going to call a microservice, another microservice, and we're going to channel a lot of calls like that, I might end up with queries that are going to be very slow because I've added a lot of network round trip. So that's another risk when you do microservices. Testing. So testing gets very hard with microservices because when you have one microservice that interacts with other microservice, if you want to do proper unit tests and functional tests, you have to mock a lot of calls. You have to do some work at the test level that are a little bit hard, and that wouldn't happen with a monolithic application because everything is under the hood. So that's another problem. And another big issue with microservices, there are a lot of issues with microservices. I hope you're not discussed at this point with them, but anyways. Data storing and sharing. For example, if you start to store in a microservice information about your user, and then another microservice needs to interact with the user information, how do you interact between the two microservices? Are you sharing the user email, the user ID? How do you do that sharing without making the two microservices interdependent? And what happens when your database changes? Is this going to impact other microservices? So that's, again, another problem with when you create microservices. You have to be careful about what you share between microservices because every time you're going to change something within your microservice, it might impact other microservices. And last but not least, compatibility issue. So when you have to change the way a microservice works and you want to publish the new version, like a typical application, what happens with all the clients? What happens if your microservice is used by many other microservices? Do you set up some kind of migration path? Do you have to ask all the other microservices to change how they call your app? That's not easy. So that's again, another problem with microservices. But fear not, there are a few key principles you can use to try to avoid most of those risks. So I have 3 principles I use when I build microservices. So the first one is never, ever, ever try to create microservices on day one, even if it's fun to create a bunch of microservices and go on the whiteboard and create a lot of squares and arrows, and this one is going to call this one, etc. This is a recipe for disaster because it means, I mean, you can't get the right design on day one. It's impossible. You have to iterate, you have to mature your database model until you have something that you understand that works really good. And that's when you can start to split out of your main application some microservices. But until that point, do not try to create microservices when you start a project. That's really bad. And that's related to the second key principle, which is perimeter splitting is the root of all evil. Basically, if you want to split out of your application a microservice and you're not sure about how it's going to interact with your main application, just don't. Don't split out the microservices. You have to do it only if you're sure it's going to work out. And last but not least, as I said before, when a microservice has some data, and you are going to reflect some of this data on your microservice API. Don't try to design CRUD microservices. So CRUD stands for create, what's the R? I forgot. Okay, so all right. So if you have a database and if your API looks like the database, like, hey, I can create objects, modify them, delete them, well, it's not a microservice. It's just a database, and it means that every time you're going to change your data model underneath, you might impact your API. So you should be careful not to do this. You should have a HTTP API that don't reflect the database, but provide actions, provide behaviors like, I don't know, like, hey, send this report to this user, or do this, do that, but don't try to reflect anything that's underneath the microservice, because that's going to be a problem the day you want to change your database. All right, so standard protocols. So there are a lot of cool protocols you can use to build microservices. You can use HTTP2, you can use plain socket, or I don't know, WebSocket, you can use message pack, you can use binary protocols. But at the end of the day, a good old HTTP1 JSON API is what works the best. Why? Because when you create a microservice that implements a JSON API, everyone everywhere understand how to use it and how to interact with it. It's like the gold standard. And even if other people don't use Python, shame on them, they can interact with this stuff anyways. RESTful design, well, so RESTful means that you put in your endpoint some kind of standard where I don't know, /users something RESTful where instead of doing like in RPC, putting action in the endpoint, the action is the verb, put, post, delete, etc., and the endpoint is the intent. You can do that. It's something people understand. If it's not fully RESTful, it's okay. You can call it RESTish. That works, as long as you have a versioning API in the endpoint. This is really important because the day you create the v2 of your API, you'll be happy to be able to add /v2 as a prefix of your API. And you can use Swagger. So how people, do you know Swagger here? Yeah? Cool, okay. I don't know why I'm doing a presentation, you know everything. So Swagger is, I'm gonna say it anyways. Swagger is a specification, a JSON-based specification where you can say, hey, this is the list of my endpoints. And you can publish this Swagger specification at the root of your microservice, /spec, whatever, and people can read it. It's machine parsable. It means other tools can use it. You can use a user interface to play with the API. It's pretty nice. And I would say that the biggest benefit of using Swagger is for yourself. When you take the time to make sure that your Swagger specification is square, and when you reread how your endpoints look, it's usually when you understand, you find out that it doesn't make any sense. So using Swagger is a good way to document your API and for yourself to increase the quality of your web services. And Swagger is also based on another stuff called JSON schema, which is basically something you can use to validate the inputs and outputs of your HTTP APIs to make sure that the JSON you get follows a specific schema. And last, so token-based authentication, when you have a bunch of microservices that needs to interact with each other, they will probably be deployed on several boxes, and you need them to interact and to authenticate which is other. So OAuth 2 that we can use to authenticate as a user to a plain website also has a way for machine-to-machine connection using tokens, and we'll see that after. So that's basically what I use to build microservices. So HTTP, JSON, RESTful design, a bit of Swagger, and some token-based authentication. All right, so when you design HTTP APIs, like I said earlier, you don't want to do anything that looks like CRUD. You want to try to be as concise as possible, and you don't want to surface a lot of details that are within your microservice. You want to have an API that publish a behavior that publishes how your feature works. And there are many, many great examples out there. If you look at like the main vendors that provide APIs, it's a great way to look at for examples. You want to version your APIs, and if you can, you want to make sure that every time you create a new version of your API, it's backward compatible. Because when you do something that's not backward compatible, it's a pain in the butt to deploy to make sure that everything works. And to give you an example, when we've created the second version of Firefox Sync, the protocol, we ended up not shipping it for over a year because it was such an issue to have something that would work great for the millions of users out there that was still using the first protocol. We invented a lot of hacks to try to have the old client move to the new protocol, and it was horrible. So if you can avoid creating something that's backward incompatible, that's really good. And last, try to use JSON schema if you have complicated data that goes in and out, because it's a great way to make sure that you reject anything that looks funky, because people that are using your microservices will send crappy requests, that's for sure. All right, so far this was all theory. So this is a conference about Python, and so I'm going to show a little bit of code, and I'm going to talk about the application I'm building for my book, which is called I'll say it in French, Runnerly. How many people are running here? No? Yeah. Okay, so I love running, and I use Strava daily. It's like Twitter. I'm always on Strava to look who's done a run and stuff like that, sending pictures and stuff. Anyways, and so Runnerly is an application that interacts with Strava to grab some runs and try to do smart stuff about it. So I want to add some. It's not. It doesn't exist yet. It's something I'm doing for the book. And Runnerly is going to pull data from Strava and do some computation. Like, for example, I want to know in all the Strava people which are the one that runs a little bit like me or do the same kind of training. So I can like socialize with them. Hey, this guy is crazy like me. He runs all Sundays. Maybe I can do a few runs with him because he's in my neighborhood or whatever. So anyways, and Runnerly is a good case study for microservices, because when you think about it, an application that interacts with another service like Strava and pull data, do some backward computation, to do some smart reporting, it's perfect for microservices. Well, if it has 2 users, it's overkill. But if you project yourself, if in 5 years I'm rich because I've pushed Runnerly and there are millions of users and stuff using Runnerly, then it's great to have microservices for this app. So this is the architecture. The logo here looks weird because the slide was white on black on white, and I reverted it, so that's why the color is strange. So this is Runnerly, and Runnerly has 1, 2, 3, 4, 5, 6, 7 microservices. So this one is the dashboard. It uses React to display some stuff, and it interacts with Strava to do the OAuth 2 dance, so I can connect with my Strava account. This is a races web services. It has a races database, and where I have a list of races. This is a data service that has all the runs and users' data, and the training plane service is a service that reads that you can use to create a training plane. Let's say you want to train for the Poznan marathon. You have a marathon in Poznan? Okay. You want to train for the Poznan marathon, so you enter the date and you say, hey, I want to train 3 times a week. Please create all the training for me. So this little guy here is going to generate some runs for you that will appear in the dashboard. Perfect example of a microservice that can be useful. And those 2 are workers. This one will read the runs you've done in the month and generate an email with a summary. And this one here will just interact with Strava to grab your runs and put them in this app database here. And the token dealer is for authentication, and RabbitMQ here is used for everywhere here to grab and send some events. So how can we implement this in Python? Well, obviously you can do it with any framework. You could do it with Django, that's for example. But when you write microservices, you want to stay lightweight. You want to have something that's closer to vanilla Python as much as possible. And micro frameworks like the one I've listed here are perfect to do this. So there is Bottle, Flask. So I don't know if you know, but Bottle was created before Flask, and Flask was named after Bottle as a joke. And after it became a serious project. But when Armin created Flask, it started as a joke. Connection, which is made by the Zalando team in Berlin, I think. It's based on Flask, and it uses a Swagger definition to create microservices using Flask. It's an interesting approach because what they ask you to do is to write the Swagger spec, and then the code is automatically generated from there dynamically, so you don't have to actually do any routing. You just have to provide your Swagger definition and your function, and it works like that. So it's pretty cool. AIO HTTP, which is like async framework based on Python 3 async IO. Falcon, I've never tried it, but I've heard a lot of good things about it. Twisted, the grandpa, but which is really fast and great if you don't mind not having a lot of documentation. And Tornado, which is pretty cool too. And my choice, as of today, is Flask because it's very mature. It has a rich ecosystem. Every time I'm looking for a feature, I just type Flask feature, and I often find it. So it's pretty cool. But right now we've reached a point where doing async programming in Python is now very, very real, and it works well. And probably this year and next year, we're going to move everything to AIO HTTP because it's just better. Asynchronous programming is just faster. I mean, when you run a Flask application, one process equals one request. And so if you want to scale, you have to create to run a bunch of processes. If you try to run a multi-threaded Flask application, you're up for some trouble. So on the other hand, if you run an AIO HTTP-based application, like you would do for Twisted or other asynchronous frameworks, you're just going to be able to handle hundreds and hundreds of concurrent requests compared to one request for Flask. So, I mean, why not using that now that Python is mature enough for doing async programming? But let's stick with Flask for now because all my examples were made for Flask. So this is a full micro. Do you guys use Flask here, or yeah? Okay. So this is a full implementation of a microservice. This program will run a microservice on API v1 foo and return some JSON. And this is exactly in the spirit of microservices. The code is a few lines, and from there I can grow a feature. I can start with this very simple module and iterate and create something that works great for a microservice. If I want my microservice to interact with Celery, so Celery is a tool you can use to send some work in the background. It listens to a broker, a queue, where you can send some work, and you can use different backends for that queue. You can use RabbitMQ, Redis, and some others. And in this example, I'm using Redis. So here, this is a full microservice using Celery, and this microservice will listen to a queue, a blocking queue on Redis, and will do some heavy computation every time someone sends some job to do on the heavy queue in Redis. And as long as what you're sending through the pipe is pickable, that works great when you need to build a microservice that gets a job from another microservice. So when you are on the other side, if you want to send some data to Celery, you can use the same class Celery and just send a task to the other one. So now, when you're creating microservices, you don't want to import the code from the other microservice. Here, this is a full microservice. I'm going to ship it and release it as a standalone microservice. And here, I don't want to have to import the code of the other microservice. So instead of doing like 99% of the documentation about Seri says, hey, import your task and call it with the async method. Here, I can use the send task generic function and the name of the task, because when Seri creates queues in Redis, it will use the name of the task you use to create the task. In other words, I don't have a code dependency between the two microservices. All I have to have is the name of the task to send some tasks to that broker. So here, it sends the task to Redis, and then go back to the request and answer to the user. And it's not blocking. All right, so I've said earlier that in Runnerly we use RabbitMQ to do all the messaging. So messaging is a very important feature you need to have when you have a microservice-based application, because you want to be able to do a loosely coupled event system where you want to tell other part of the system, hey, this happens. Do whatever you want with this information, but it happened. And so, for example, here, race number 34 is finished, and I have some results. I don't know, I don't care who wants to use them, but I'm going to tell the word that race 34 is over, and we have some results. And I can send that to RabbitMQ using Pika, for example. There are other lib, but I like Pika. And this small function here will connect to the RabbitMQ incoming queue and push that message into the queue. And once this is done, it's a fire and forget. I just sent a message, and depending on how your RabbitMQ server is configured, other will pick the message. And so to consume RabbitMQ events in microservices in Python, if you're using a sync framework, you can use there is a RabbitMQ JSON plugin you can use that will do some post calls on HTTP endpoint every time the message comes in. The problem is this is not something you manage yourself. It's all in the RabbitMQ server, and in case you have an issue, you don't have a lot of things you can do about it. And there is another way you can do that. You can write yourself a small Python script, a RabbitMQ to HTTP bridge, that will listen to the events, decide what to do with them, and redispatch them to other microservices in case you want to do that. And for async framework, it's not an issue. In your microservice, you just have a callback that's recurring, be called in the event loop. And so like every other minute or so, you're going to call that function. It's going to check for the RabbitMQ queue and grab any message that's pending. So the bridge, so that's the other side of RabbitMQ here. I'm just creating a connection that will consume the incoming message in the queue race. And every time a message appears here, I'm going to call the onMessage function. And the onMessage function here in this example will simply relay the RabbitMQ message to a Flask application. And I really like to do it this way because it means I can grow this little script here to do specific stuff depending on my needs. Calling other services. So if you use something like Flask or Pyramid or Django or anything synchronous, I think requests is the best lib to do it for two reasons. The first one is that the session object in request is highly customizable. You can plug a lot of add-ons in that session object to do some specific retry on failures, to handle all the timeouts and stuff. And at the end of the day, once you have configured your custom request session, you can just use the plan request API to do interaction between your services. And so that's the one I recommend when you do synchronous calls. If you're async, well, it's easier. You just use the async lib from the standard Python library, or if you use AIO HTTP, you can use the client-side session class. It provides similar features than requests. It might have less option. You might need to do a little bit more of coding, but it's very efficient. All right, so that's the last part about run early. I'm going to talk a little bit about authentication. So if you want to have two microservices that interact with each other in a secured way, you can use OAuth 2, and in OAuth 2 there is a process called the credential grant, which lets you trade, which lets you interact with your token server and get a token you can use to authenticate to another server. So here, service one asks the token dealer, hey, I'm server one, you know me, we've met the other day. Please give me a token, I want to talk to service two. Oh, yeah, okay, I'll let you do that. Here is your token. Hey, service two, it's service one, I have a token. Oh, are you sure about it? Let me check it. Okay, so that's basically the process. Like OAuth 2 for humans, but only between machines. And the token dealer here is the master of ceremony. It knows all the services. It knows how they should interact between each one of them. And it can issue tokens for authentication. And that uses the JSON Web Token standard, which is a standard that goes with OAuth 2. And basically, it's a JSON mapping containing some information, like when the token was issued, when it's not valid anymore, what's its scope, like, hey, this token is only for read access, you're not allowed to do write access, et cetera, et cetera. And you can add your own information in that token. And it's encoded, so you can use it in your URLs or headers, and signed. And there are two ways to sign tokens. The first one is with a shared secret. So you have a secret, and with this secret, you're able to sign or verify a signature of a token. And if we go back to the initial design with my 6 or 7 microservice, if I use a shared secret, it means I have to share it among all microservices. And that's a big security issue. It means that if someone breaches into one of the microservices and get that secret, I'm screwed. Everything is going to be broken. I could use something like Apache Zookeeper, maybe, to share that information, or something fancier, I don't know. But there is another way. The other way is to use a private and public key, where instead of having a secret shared amongst all the microservices, the token server has this private key and signs the tokens, and all the services have the public key and can control the token without having to have the private key. It's a basic key pair encryption. And it's better, it's more secure. The only problem is that when you do that, your token, which was like this in terms of size, become like a big, huge chunk of data you have to shove into your requests when you do some calls. So that's a trade-off. If all your microservices are private to your company, and you can like share a secret and nothing goes on the web, shared secret is perfect. Okay, that means I have 5 minutes? No? Oh, okay. Blah, 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 private key, better, bigger, up. So, so this is how you can authenticate in Flask using a token like that. It's a summarized version, but basically You shove the JW token inside the authorization header, and then you can use the gwtlib to decode it. And when you decode it, it's going to verify if it's valid, if it's not, if it's still, didn't expire. It's going to extract the payload, and from there you can go ahead and do whatever you want with the user, because you know who is this user, a service, for example. You know if the service is allowed to do some read or writes in your application, etc. And if it's not valid, you just abort the call. Testing microservices. So it's hard because of all the moving parts. You should make sure that you have, you're able on day one to have a full stack working on your laptop. If you can't do that, it's going to be hell to develop in your microservices based environment. You have to make sure that you have a reproducible dev deployment. You could use Docker for this, for example, but you have to make sure that when you work with a stack, you know how all the parts are interacting with each other. Unit and functional tests, so you could use, if you use requests, you can use requests mock to mock some of the calls, but this is not like real life. Never push something in production I mean, sometimes I see people saying, hey, I have 100% coverage, my tests are fantastic, everything is covered, and then when they push in production, everything breaks because they've used mocks that didn't really reflect reality. And there is the best way to reflect reality is to do something in real. And so that's why integration tests are important, and that's why you should always have some tests that tries to do some functional and smoke tests against your API in a real deployment with all the pieces in place. And you can use, for load testing, you can use Molotov, which is really cool. Deploying, so CI all the things, but I think all the people here in this room are like expert at this kind of stuff, so I won't say a lot about it. Use Travis CI or Jenkins or Circuit CIs, Docker all the things. Never, never, ever, ever deploy a database in a Docker image. Never do that. Use the cloud, Luke, check native cloud tools. I mean, if you deploy in Amazon, you shouldn't use RabbitMQ or tools like that. They have queues, they have everything on Amazon. So it's better if you are going to deploy something on a cloud vendor, it's better to use their tools and not bother having to manage your own deployment if they already have all of that. I mean, you pay for it and you just yell at them if it breaks. Monitoring, so Datadog, you can send some stat-D stuff and follow what's going on in your microservice. Sentry for traceback, but what I really like is Graylog because it's a mix of both. With Graylog, you can have both traceback and performance and everything you have in stat-D and in Datadog. And unlike Sentry, in Graylog, you can send UDP traceback. You can send you tracebacks using UDP. Graylog will push them in an Elasticsearch cluster, and then you have like a very powerful query engine to look for all your traceback and whatnot. Conclusion, Python is great to write microservices. It's great for many things, but in particular microservices. I think it's one of the best ecosystem right now because I can't think of anything you can't do with the existing libs you could find on PyPI. But microservices are dangerous. Be super conservative. Don't start an application thinking, hey, I'm going to create a bunch of services, of microservices. Just start your application, and then when it makes sense, you can split out a few microservices out of it. Because sometimes having a single application is much less pain. And this was like a super condensed version of this book I'm writing, which should be out sometime in the summer. That's it.
Yeah, thank you, Tarek. We still have time for a short Q&A session.
Okay.
We can shorten our coffee break, can we? So let's start maybe with Tomek was the first.
Thank you. It's working, yeah. I've seen a couple of different approaches and heard a couple of different opinions about data storage in microservices or service architecture. What is your approach and why?
So the question is, what are my thoughts about the different approaches?
Or what is your suggested approach to how to store data when you have a bunch of services?
Okay. It's a hard problem. I don't think there is any silver bullet because as soon as you start to share data, you're in trouble anyways. I think the best approach is to try to have a unique identifier for your user across all microservices. For example, an email is a good way to have a unique identifier for your user across microservices, and then internally each microservice can handle users with specific IDs and stuff like that. But an email is something standard you can share across all microservices. And as far as other data goes, when you publish data, you should be super careful about what you publish. You should publish the minimal data possible and separate it from your implementation. Like, for example, let's say I have an application about running, and I want to publish some runs. So I'm going to create a separate document, separated from all the microservices, when I will say, hey, this is how I specify a run, this is my list of fields, and this is my V1 of my data, and this is separated from all the microservices, and it's a spec. And I treat it like a spec, right? So that's one way to handle the problem.
So, for example, if one service that handles, creation of runs wants to delegate the task of sending an email to another service that, sends emails, do you pass the whole object, or do you pass just the ID? And then, if just the ID, where does the other service take the data from?
All right. So if the data I'm going to send through email is available as a microservice, I'm just going to send the ID. And the stuff that do the email generation can call the other microservice to get the detail, right? So that's one way to do it. If that information is not available, I might just send the whole JSON payload so the template just generates something out of it. That's another choice.
In other words, if I got it right, your approach is to have each service handle its own data while talking to the database, storing it, and exposing it only through the API.
Yes, you don't share databases between microservices. This is a recipe for disaster. You want to isolate your database per microservice, and then specify the smallest surface, the smallest thing between services. That's my approach.
Thank you.
Welcome. It's a lot of sun.
Radek? Oh, sorry.
Thank you for the speech. It was really interesting.
Thanks.
Just wanted to ask about the principle number one. You said because the example that you provided just breaks it. And my question is, in the real life, would you start designing the application that you provided as an example as a monolith app, and it would be the result of the composition, or would you start with the? I mean, because it looked really, really, really interesting, and really, it gives you a temptation to make a design of microservices at the beginning. And so the question is, would you rather advise to start with monolith app and then decompose it
yes,
step by step? Yep.
Right. So I cheated a little bit here, because when I did that, I did the monolith version first.
All right.
And one chapter in my book presents that monolith. And then I split it in microservices. This version, maybe it's not going to work in real life because it's not in production with many, many users, and maybe it's wrong, but I think once you get used to how microservices work, you get it right better. But I still encourage people to start with a monolith and then split it when it makes sense.
All right, thank you. Thank you very much.
Hand it over, please.
I had a question about the slide with the free services, the one with token resource. So when you fetch the token with the first thing you do, really, and then when the service that just got the token, the second step, when it authenticates with service 2, you trust the JOT only by the verification of it, either by the secret or the key?
So here I have a public and private key pair. And here, when service 1 asks for a token, the token uses the private key to sign the token. And when it sends it to service 2 has, the slide is not well done. I should have put the public key here. Okay. It has the public key, and with just the public key, it can verify that the token is valid.
And you wouldn't recommend any other communication with the token dealer, which I assume is an authentication service or a user service? You don't fetch any other data. We don't recommend that. You would, I guess, a user ID would be contained within the payload of the JOT.
Yeah, I don't recommend. Well, okay. You could ask the token dealer if the token is valid. You can do an API like that. It makes sense if you don't want to do a lot of CPU encryption work here, because it can be a problem. So yeah, you can have a verification endpoint here. But what I wanted to show here is that the service 2 could, in a standalone way, find out if the token was valid or not. So it depends on how you do your architecture. That said, you have to be careful when you give the public key to all the microservice. It has to be manual, because you can have a man-in-the-middle attack. If someone gets the wrong public key, it could be a problem. And the same goes for the API you do for checking the...
Okay, but passing everything in the payload and verifying it's on its own with the public key is a fine approach, you would say.
It's one approach. The other approach is to ask the token dealer to verify. And usually they do that, they provide a /verify. You send the token, and it says, yes, it's valid, and this is the content of the token.
All right, thank you.
Okay, so for web services, for HTTP-based web services, what are your suggestions for implementing communication between such services, asynchronous communication between such two services?
Okay, so that's a great question. All right, so this would be this one. Here, let's say you have a React application that interacts with everything, and there are two ways to do it. You could have here a Python application that serves the React file and that proxies all the calls everywhere. That's one way to do it. It's simple because it means that when you do the connection, you don't have to deal with a token on the client side. You just do like here, OAuth 2 authentication with Strava, and you don't have to deal with the token that's inside your system. You just have one single authentication thing that's surfaced. But everything is proxied through a single point here. And the other way is to have your React app interact with all your web services using service workers, web workers, and dealing yourself with storing the tokens in the local storage. But that's a lot of work. So that's the other way people do it. I would recommend doing a classical application and proxying everything through a single app.
Okay, but I must rephrase my question.
Okay, that was not
so. What I wanted to ask is that I have one web service, so HTTP-based web service, and second one, and actually first one needs to call another, and I want to make that call asynchronous.
Yes.
So I cannot serve the results immediately. I would like to have, let's say, I could do a callback. But and now we can do some more fancy things. And I am asking you, what is your recommendation for making that asynchronous operation between
you have
web services?
Okay, you have a web service that calls another web service.
Yes.
But you want to do it in the background. Yeah?
I don't expect results immediately because they cannot be produced immediately. I could make some very long call over HTTP and hope it doesn't time out. But again, what is your practical recommendation for such scenario, or is it just don't do it over HTTP?
Well, you can use Seri. So this was an example I presented. When you use Celery, you can send your task in a queue and return immediately. And another process, Celery-D, is going to do the work. And whenever it's ready, it's going to post the result into wherever you want. And so that's one way to do it. Does that answer your question?
So don't use HTTP. Well, that is what I am hearing. Or should, okay.
Well, Seri is a TCP server, so it's like HTTP.
Okay, but there is no way for me to get notified through the HTTP that my results is done, right? They're not like WebSockets, nothing.
Oh, you mean like a bidirectional stuff?
Yes.
But asynchronous. Or you want to block and wait for...
I don't want to block.
Okay.
Yes, that's okay. Oh, well.
Well, I don't know. Maybe we can talk after about your use case, because I'm not sure. But I think, you send some job to be done and you wait or not. And then at some point you can trigger an event saying, hey, the job is ready. And that trigger can be a HTTP call or a RabbitMQ event.
Okay, so callback.
Yeah, a callback. Okay. And that's what I did here. In RabbitMQ here, I'm doing a callback here. The message arrives, hey, I'm done. The job is done. And here I'm calling a HTTP callback here.
Okay, so both web services need to know about each other to do this, and this is the way that you suggest to do it, if I want to use it.
You don't need to, you don't need to. Here, this would be part of this web service. It's a small bridge that grabs events to call back this HTTP API.
Okay.
Well, I'm sorry if it's not clear, but I'm happy to talk about after that, and we can hack on it.
I will explain more in detail what I actually expected to hear.
Cool.
Thank you.
Yeah, I encourage you to catch our key guest later.
Yeah, ask me all the question before my third beer tonight.
Hi. I'm really glad you mentioned that you should not decouple into microservices from day one, because my experience is that some people do that just because they heard about microservices and they think it's really fancy. But is the performance the only one deciding point that you should make the decision on when to decouple to microservices, or are there other areas that should affect the decision?
I don't think it's the performance, because if you do a good job in a monolithic application, it can be super fast and even faster than microservices actually. But that said, when you want to scale, if you have an application that's doing reporting for runs, and it uses a lot of CPU to call, report lab, and then the rest of the application is just displaying pages, and you end up using the CPU to do all the reporting, and the website is down because of that, having a separate microservice is a good way to solve this scaling issue. So it's not about how fast it takes to do something, it's about resources. It's about saying this feature uses a lot of RAM, but I can use a microservice and have a tweaked server with a bunch of RAM just for that feature. And here, this one uses a lot of CPU. I'm going to use a server that has a lot of CPU, but I don't care about the RAM. So it gives you more options like that. But I think microservices are good for separation of concerns, and I have a good example. I mean, one of the examples I have is when you want to add a feature that's isolated enough in a big application, and you give it to someone that doesn't know this application, it's easier to outsource it or to give it to someone that's new to the project if you ask the person to create a microservice. So that's another use case for that.
Okay. I have another question. What do you think about this kind of approach that, let's say you have like monolithic application, but you scale it through, to deploy this application to multiple servers, but you make some kind of routing through, for example, NGINX. Like on one server, you just use one module from this monolithic.
Yeah. Well, we did that in the past for some projects. The problem is when you have a monolithic code base and you're going to change something in a module and that doesn't have anything to do with, let's say you change feature A and it doesn't have anything to do with feature B, and you deploy both features and feature A breaks the other feature, it means, because it's in the same code base, the fact that you don't isolate the two features and you have the same code base and deployed in different points make it less robust, because when someone changes some code here, it might impact some code there.
So basically, every change you make to any of the modules, you have to deploy to all the servers.
Well, if you don't want ops to hate you, you should do that. You should only have a single version of an application deployed everywhere. Because if you have like 10 different versions of the application, it's a nightmare. So yeah, you should deploy always, if you have it deployed in several places, it should always be the same version. And if I change something that doesn't impact the feature I'm deploying there, it's better if it's not deployed there as well.
Okay, thank you.
I'm really sorry, but okay. Just one single last question, right? Here you go.
Hi. You said the database should not be in Docker. Can you say more about it?
Okay, so Docker images are a great way to deploy something, and you should consider it as something that can be shut down, restarted, trashed, etc. It should be treated as something that's not persistent. And the reason is when you deploy Docker, there are in like 6 months ago, we had some issues with some Docker file disk that were corrupted, and that was a nightmare. And we decided that it was best if a Docker image is only code, and that everything we want to keep, like databases and files, should be externalized from the Docker image. So that's the main reason. A VM like Docker should not contain any precious data. You should create a bridge or link something outside the Docker image, because it works as well. And it means you can use, like, if you're on Amazon, you can use RDS or stuff like that. And in case the Docker crashes, you don't lose your data, because a VM is not just a simple file system. It's like a black box, and if something bad happens, if there is a bug in Docker, and if it screws your data, it's not good.
Okay. So what you say is that database server can be in Docker, but data should be outside of the Docker.
No. I wouldn't use Docker for a database. Because I don't trust Docker enough on the file system level.
I hate to cut this interesting conversation, but we need to finish this this session. Thank you, Tarek, for having.
Oh, I have one announcement. In this summer in Paris, there is Pi Paris in June, and we're looking for some speakers. So if you go to piparis.org, you can, and if you want to come to speak about Python in Paris in June, it's beautiful, sunny, and it's fantastic, and please come.
Thank you.